take your seats. I've had a lot of people ask me questions about what our attendance is like this year. So you can see from the screen, we're in a very hot market, robotics is. And so it's very exciting. We can't exactly explain the spike in interest in this year's conference, but we're thrilled that you're here and hope you've been enjoying the week. So it's my great pleasure and honor to introduce our plenary speaker this morning, Helen Greiner. I met Helen, I believe it was 1989, when we were both students at MIT in Rod Brooks' Mobile Robots Lab. I owe my research experiments for my PhD dissertation to Helen because she built the R2 robots that I used many years ago. And so she has had an entrepreneurial and innovative spirit since I've known her. And so it's my great privilege that we have Helen with us here today. Helen is the CEO of Sci-Fi Works, which is a company that she started in 2009. That is after she co-founded iRobot Corporation with Colin Angle and Rodney Brooks. And you're, I'm sure, all familiar with the Roomba robot and the PackBot robot. So that company has been a great success, and we know that her Sci-Fi Works will also be a great success with the aerial robotics that she's working on now. So she has a bachelor's degree in mechanical engineering from MIT, as well as a computer science master's degree from MIT, and an honorary doctorate degree from Worcester Polytechnic Institute. She served as the president and chairman of iRobot for many years, and she's highly decorated for all of her contributions. She's recognized worldwide for her entrepreneurship and innovative thinking. Last year, she was named as a presidential ambassador for global entrepreneurship by President Barack Obama. She was named by the Kennedy School at Harvard as one of America's best leaders, and she was named as an Ernst & Young New England Entrepreneur of the Year. She served in many capacities, such as trustee for MIT and many other areas. She's very highly decorated for all of her accomplishments. So we're thrilled to have her here to come tell us about her new endeavors at Sci-Fi Works. And if you like what you see today, I'm sure she would be quite happy for you to pitch in her Kickstarter fund for her company. So without further ado, I'm happy to welcome Helen Greiner.
Well, thanks everyone. It's certainly an honor to be asked to speak at ICRA. When I was a student, I went to ICRA, and it was wonderful how the senior robot gurus in the land welcomed the students and made them part of the community, and that has really stayed with me. So, Ken Salisbury with Uesama, it was really a wonderful first experience. So I encourage everyone to make those students feel as welcome many, many years later. So I'm going to speak today on innovation at startups, a topic that I'm extremely passionate about. It's, it's what I've done most with my career. As many of you know, I've got a new little robot in my life. She's here at the conference. Hopefully she'll be on the boat trip. So she's really changed my life a lot, and I just have to say how wonderful the program organizing committee for this conference is, and I'm sure you all agree because of the attendance and the quality of the papers. But they convinced me that it's no big deal to travel 3,000 miles with a 4-month-old baby. So that's how good they are. And what do I know? I didn't have any kids at the time. So innovation at startups. I believe that innovation it can be business model innovation, but if you're a startup, you better be doing something new, because otherwise you're not going to be able to compete with the people that are already in the market. I'm going to concentrate on technical innovation today, because that's what, we're at ICRA, and that's what I know best. So many startups are formed around a particular technology, like Google with PageRank and many others. But you really must continue to innovate to survive. They didn't rest on their laurels with that. They innovated an advertising, a new advertising business model. And it's really important to continue to innovate because we live in such a world today that there are many, many fast followers out there. There's many sources of funding. As soon as something's working, people will jump in. So you really have to set up a culture of innovation at a startup company. And you have to realize that innovation can come from anywhere at the company. There are many that have a top-down model of the universe, and it gets reported a lot that myself, Rod, or Colin at various times, invented the Roomba. That's not true. There's some folks who came up with the idea. There's many folks who invented a lot of technologies along the way. It's a whole team approach, and innovation and the ideas can come from anywhere at the company. The job of management is to recognize a good idea and to promote it. And the goal is more market share, more markets, and margins, the M's. And I almost hate to say it in such a room of with such quality academics, but it is about the money. And money fuels more investment. Money fuels, your internal research and development budget. If you can get a jump on that, you can feed it back in and create that virtuous cycle of, having iRobot be successful and being able to take it public actually drove a lot of other companies, enabled a lot of other companies to get funded because investors could look at, these guys got a really strong 50 times return on investment for the initial investors, and that really helped a lot of other startups. So it is, hate to say it in this community, but it is about the money as well. And the innovation has to be driving market share, more markets, or margins. So these are some of the examples I'm going to use of innovation today. And I'm not for the particular innovations because everyone's working on, there's so many different areas in robotics that are coming up right now and getting that first commercial taste of success. Our innovations aren't going to be your innovations, but there's some key points about them that I'd like to highlight that might be informative as some of students, some professors, and others might be looking at an entrepreneurial venture. So the first goes back to my iRobot days in tactical robots. In the mid-90s, we started looking at building a tactical robot. And we had been taking some of our robots we were delivering to professors like Lynn and saying, well, how can we make these more commercially viable beyond the research lab? And tactical robots was one that we came up with. We were fortunate that DARPA started a program about the same time, maybe about 2 years later, and really started to look at what the customers need. And in this case, it was a military customer base. They needed to climb stairs because, well, stairs exist worldwide. They needed it to be really rugged. They needed it to be really lightweight. And at the time, this was in the So the PackBot of innovation was adding 1 degree of freedom. There's a total of 3 with the wheels, but adding 1 more degree of freedom. And we discovered with that, so the PackBot of innovation was adding 1 degree of freedom. There's a total of 3 with the wheels, but adding 1 more degree of freedom. And we discovered with that, well, that enabled stair climbing. There were some articulated tracked vehicles at the time, but many of them had tracks on the front and the back and the center of gravity in the middle for a stable base. We were looking at climbing, so we shifted the center of gravity forward and looked at what you could do with just 1 degree of freedom. And it turns out you could do quite a lot. You could go over rough terrain. You could crawl if you get into trouble, do the Australian crawl. You could use it to lift a camera. You can use it to self-write. You can use it to get sensors up higher. There were these whole new ideas, but they also needed to be really rugged and really lightweight, which kind of made it so this was a better design direction than the multi-articulated systems that some others were working on. And the wheels and the tracks also really protected the body. So this is a very old video. I'm a little embarrassed to say I took it myself. We used it so much in the 90s at iRobot. And you know, when I first showed it to people, it was a different time, right? But you know, I would actually get applause from the audience because people had never seen a robot that was designed so much to go out in the real world. So this is one of the very early generations of the PackBot systems. We are cheating a little. We have a radio control in it. We didn't have our computer systems up and running yet. But for the first time, it would be able to climb stairs, be able to really have the kind of treatment, you know, our customers, sorry, yeah. So this is how the PackBots sometimes go into the field, or I should say come back from the field. They're going out and disposing of munitions. And you know, this one, the Marine who was in charge, he carried it back in to the robot hospital over in Iraq and said, "Can you fix it?" And you know, we had to tell him, well, no, we can't fix this one. But he was really attached to it because it had done many missions for him. It had done vehicle missions. It had done you know, UXO missions. It had done a lot of IED missions, and he had, you know, grown really attached to it. It was like it was his robot, and you know, he would think about it as one of the team, and I think the way that innovation differs as a startup, there were a lot of people working on this DARPA program, and there was a lot of great other research done that built the built the knowledge base. But as a company, as a startup company, we were able to push it forward after that program ended and push it into the field. And now we've got over 6,000 of them out in the field. We were told they couldn't have done, by the Japanese, we couldn't have done the cold shutdown of Fukushima without having these robots ready to go, going into that environment. They were used in Boston when they were capturing these Boston Marathon bombers. And it's really one of the things I'm proudest to having spearheaded and pushed out from research into real-world applications. Which brings us to robot vacuuming. There were a lot of innovations on the Roomba. I'm just going to speak about one of them today. The customer need was to have it clean along walls. And why? Well, because that's where the dirt, you know, hangs out. We also had to make it really price sensitive. There was another robot vacuum on the market in Europe at the time made by Electrolux, but it was thousands of dollars. And consumers, you know, are pretty price sensitive, especially when it's a new technology and they're first trying it out. And so we started looking at what you would need to do this, and wall following. The European system used a sonar system, which was quite expensive and quite noisy. We had a lot of design, what you would call a hackathon today, where engineers came up with different solutions. And I remember going to meetings and looking at people with whiskers coming out of the robot, running along a wall. And we had to squash that one because whiskers running along or somebody's nicely painted wall is probably not a really, really good rugged idea. And so that would scratch the paint, so they added a little roller onto the whiskers so it wouldn't cause any damage, but still it wasn't ideal for a home environment when you have whiskers sticking out, and you might have something on the floor that it could, your dirty underwear's there and the whiskers are catching on it. And then, infrared ranging was one of the options for the low cost. And we had a lot of robots at the company that we were getting into research labs that used infrared ranging. But when we took it to all these homes, and there were different lighting conditions and different reflectivities of the surface, it just didn't work the same in all environments. And that was a big, big issue. So one of the innovations was what we call the digital IR. So instead of getting all this great range data, which was very useful for the algorithms on the robot if it was rugged, robust in all environments, but it wasn't. So it turned out to be a better option to say, is there a wall at 1 inch or isn't there? And we did that by angling the infrareds. And that is it's a very reliable method that it's still used after, oh my gosh, I don't even care to think how many years, but it's probably 13 years later. And because it was very, very impervious to noise in different environments. We had to combine that with intelligence on the robot, which is great because anytime you can push complexity into the software system, it's a real win for the whole back end of manufacture and service and support. And so with the light touch, the robot runs into a wall. It knows how big its body is, so it senses the wall with its bump sensor. It slows down with IR, it senses the wall with its bump sensor, it turns a little bit, and moves away from the wall. That gets it to almost 1 inch, and from that, it can servo on 1 inch with the infrared. And that allowed us to get the Roomba on the market at for Christmas 2002. And I put this up to make another point. This is the first Roomba. It doesn't have a charging station. Now, everyone at the company knew Roomba should have a charging station. We had designs for Roomba charging stations that weren't perfected yet. But they thought, well, it's going to end up under someone's bed, and they're going to have to go crawl under it and pull the Roomba out if it can't go back to a charging station. And so, but we put that first one on the market without the charging station because it was better for the company, for the brand, to get out on the market. Even if it's not quite every feature that we knew we wanted, it's better to be in the market first, establish the name, the brand of Roomba, and be the one positioned to get those new innovations on the market. So, the learning experience there was just because you can do it doesn't mean you should, especially if it's going to slow down getting the product out there. Which brings us to drones. I'm thrilled to have gone into the drone space. I had been doing ground robots all my career, and like many of you, I love getting up every day and learning something new, and I've been able to do that with the new company. But more than that, I think they're just a really powerful paradigm. If you look around a room like this, it could be hard for a ground robot to get everywhere. But if you, pop up a little bit and fly over the audience, over the chairs, over the tables, over the cables, over the backpacks, it can be really a much easier obstacle avoidance challenge. And the same thing outside, you have, roads and muds and streams and fences. If you're able to just fly over them, it's almost like you're cheating. And I say cheating is really good when you're trying to address a customer need in the simplest possible way. So outside, just above the treetops, just above the wire, the telephone wires, there's almost a highway waiting for the drones to do delivery and other jobs. We started out looking at what the customer need in drones was. There were a lot of drone manufacturers on the market. There's even more today, but there was still a lot in 2009. And we discovered that one of the things they really wanted was a longer time of flight.
you can collect the drone data on an SD card, but a lot of our customers wanted it in real time. And they wanted it to be secure, because if someone's getting access to your drone videos, because it's on a Wi-Fi link, that's not so great. And we want it to be unjammable, because, you know, hackers can take control of some of the drones that are out there today. But also, if you just put noise in the environment, you can disrupt the signal and make it so they're not under control anymore, sometimes activating a homing behavior. And I think that'll be, you know, as they start moving into commercial applications, hackers will do that because, hey, you can, and it's kind of fun. So we looked at the customer need time of the time of flight. The solution we came up with, that Sam Johnson came up with, was a microfilament cable, and this cable is really, really cool. It does 500 feet of length. It does 100 megabits of data, and over that same microfilament, it can do power, video, and command and control. And it's all like, you know, I think it's a 28 gauge double-banded copper cable that's insulated and has a Kevlar strengthening element, so that's a proactive constraint. So we developed that into our PORC system, which is persistent aerial reconnaissance and communications. This system works with a microfilament tether. It has a spooler to manage the microfilament cable. It has a base station that does the voltage conversions. And from that, you can get stunning imagery. This is the PORC in flight. It's attached to the ground with a microfilament cable. It's, this is part of like a 70-hour endurance test we were doing. And, you know, this is a very, very boring demonstration because it goes up and it stays up. But we really, really like boring UAV demonstrations. So this is what it's for. You can have a satellite system and you can get some great, wonderful resolution data from space. And the resolution is great for coming from space, but it's still not, you know, HD. The ground sample distance isn't that, you know, isn't that great. You can have a helicopter, but they cost tens of thousands of dollars a day to have them. With our PORC system, you put it up, it stays up. Or you have a small UAV, but then you're constantly launching and landing. And you can have automatic recharging, which I know is done in a lot of research labs. But that's usually the area where you run into, you know, it's the landing and the launching and landing where you run into any issues of you know, any braking issues. It's usually the launch or the land. Once they're up in the air, these things are very, very reliable. So, you know, we look at the PORC system as a mini satellite system. You put it up, it stays up, and from that vantage point, you have a view of your entire facility. We've also incorporated this microfilament technology into what we call a little pocket flyer. You take it out of your cargo pants pocket, and you send it into a building, and that filament spools from the vehicle. It's a, you know, you could ask why. Well, you can have a little fee flyer, but a little fee flyer this size would only, it would literally last only, you know, 10 minutes, and then you'd put sensors on it, and it would last even less, and then you'd put a higher powered transmitter on it, and it would last even less time, and then you'll only have a few minutes of operation, and that's not enough for many of our customers to get the job done. So we put the microfilament on it, and that's really changes the equation, because now it's got infinite time of flight, and you don't lose telemetry when you go into a building. So, you know, this kind of an innovation really addressed the needs of our real-world customers, which was going into a building and staying at a safe standoff distance. So the next drone I'm going to talk about, one I'm really excited about right now. It's, you know, we saw a customer need to get really stable video, but not in a very complex way. When what's typically done on a small drone like this is you have the drone, and then you have a multi-degree of freedom gimbal system that has the cameras on it, and it's compensating for all the tilting of the drone. But that's not very intuitive for everyday customers, because in some sense you have to fly the drone and then you have to fly the camera system. And people here are used to dealing with a lot of complexity, but the average customer, they just want to kind of fly the picture. And so we've creating technologies where we can do that. It also has to be really rugged. So one of our guys at the company, Ken Sebastian, came up with this great idea. We call it level up technology. It's a standard hex rotor, except we put a tilt and a dihedral on each of the rotors. And that combined with the corresponding control algorithms means for the first time you can fly a multi-rotor without it tilting wildly during flight. Or when you have a multi-rotor, a quad rotor, a hex rotor, usually it's tilting to fly. That's how it produces the thrust. We've changed that with the level 1 system, which we're really excited about. Less mechanical complexity. We talked to some hobby shops, and they told us that when people bring in their drones, it's never the drone, because the drone, you might break a prop and you can easily replace it, but it's really the gimbal system, because it will take the full force of any crash, and it would also, it just has some mechanical complexity with cables, flexing, long amounts of time exposed to the elements, et cetera. So we really wanted to reduce that mechanical complexity, and the level up technology allows us to do that. More intuitive flight controls. Once you're just flying the camera and you don't need to be compensating with a gimbal unit, we've made it so you can control it with a cell phone interface. And then we've also done some innovative work on geofencing. I'd like to just show you a video of this. I have to apologize a little bit. This is our Kickstarter video, but it's the best footage we have from the drone and the best explanation of the technology that we have. So here we go.
What do you think it takes to get high-quality drone footage like this? A professional drone operator? A cameraman? Expensive equipment? Or simply
this?
Introducing the Sci-Fi Level 1 drone, a drone that lets absolutely anyone capture footage like never before. Sci-Fi's Level Up technology is the real breakthrough. By using 6 rotors, the drone can fly without tilting, making it simple and intuitive enough for anyone to fly. Plus, you get professional, stable footage without an exposed gimbal. Because Level Up gets rid of the usual multi-rotor wild tilting, the interface can be simplified. To fly, just swipe. Swiping is a superior interface that allows you to see what you're capturing while flying, unlike tilting or joystick-only navigation. Our flying interface can be downloaded as an app on your smartphone. It's simple, accurate, and fun. Because drone flying is better when it's shared, the Level 1 can post shots and video real-time to your social network of choice. And with the new Geofence technology, you can define the area in which you want to fly. Your drone will stay within your boundaries of choice, allowing everyone from beginners to experts to practice their piloting skills with confidence.
So far, Sci-Fi Works has been building drones for industrial application. But we want to bring our drone inventions to everyone at consumer-friendly prices. Plus, we just love robots.
So really, we put our full technological expertise into designing a drone for the consumer that gives professional video quality and stability, but doesn't require professional knowledge to fly it. Our drone will come with a 1080p high-quality camera, and it will be ready out of the box for everything from family videos, to action filming, to home inspection.
So, why Kickstarter? Sci-Fi is made up of a small, passionate group of robot enthusiasts that wants to make this breakthrough technology available to everyone. And to make the leap from commercial to consumer drones, we need your support to keep the price low compared to other available drones. Thanks to the Sci-Fi Level 1's capabilities, instead of worrying about the drone itself, you can focus on the experience. The Sci-Fi Level 1 is simple to fly, captures exactly what you want, and shares it in real time. This is the first drone for absolutely everyone from the drone company, Sci-Fi.
So we have a little demo we're going to try on stage today, because what could possibly go wrong? Here's the level 1 drone. It's pretty small. I hope you all can see it. But you can see it's flying level, even when it's doing sideways motions. Microphone. John, this is John Alleman. He was running it today. He's going to be at the conference demoing it and talking about drones. I'm keeping him from doing a PhD program right now, so don't recruit him. Thank you. We are on Kickstarter right now. We're really appreciative if you're going to get a drone to support this campaign. We want to get this innovative technology. But the point I want to make for the talk is that from the time Ken came up with the idea of the level 1 to getting it up and running and having so far over $500,000 of sales on Kickstarter, it's less than a year. And you know, that's the kind of speed of innovation that's happening in robotics right now, that's happening at startup companies, which is why I really love working at startups and why I'm doing another one after iRobot. One other thing about the base, you know, we're making it so you don't have to compensate for this wild motions for stable camera, but the community is starting to put more and more sensors on these drones so it can go into more and more different environments and go into buildings and go through woods and come into the more urban type terrain. All of those sensors, if the drone's tilting wildly, need to be compensated for. With the level 1, we solve that. So if you put the sensors right onto the platform, you won't have to be always spending most of your time compensating for that wild tilting motion. So we think it's going to be a great base for research as well. You can pick up a swarm of them on our Kickstarter at a really, really great deal while we're running the Kickstarter. So innovation at startups. An innovation can radically alter the direction of a startup. You saw that with our Roomba. iRobot before that was doing military industrial robots. There were some key innovations that made, and they radically altered the direction. iRobot is 90% consumer, and you know, getting over 10 million robots into people's homes. It's really the customer need that drives innovations at startups, different from a university setting where it's the knowledge and it's you know, pushing the field forward that drives innovation. At startups, it really has to be the customer need driving the innovations. Timing is critical for success. You know, fortunately, people only remember successes, but one project that I pushed at iRobot was doing an internet-connected robot in 2000. That's a long time ago. We had a lot of excitement from customers about it, but we were unable to make a consumer price point, and the internet was just absolutely not ready at the time. People didn't have always-on Wi-Fi links in their homes, and they were a dog to set up in 2000. So I don't think we were wrong, it's just the timing. We hadn't really looked at the market timing of it, and there's a lot of companies today that are pushing this forward, and I believe they're going to be very successful with it because remote presence is a really strong paradigm. Looking at the competitive landscape is really critical. You know, with Roomba, we were fortunate to be first to market with a consumer price point, very capable robotic vacuum. Nowhere near as capable as it is today, but you know, still very capable, that got the job done. In the drone space, it's a very crowded space, so I think the winners are going to be people that innovate. And with the 4 innovations that you saw on the level 1, I think that's going to push it to success by addressing, those customer needs. And the real reason I'm doing it is because the potential impact you can have when you get robots into production and get them into people's hands is really huge. And if anyone's thinking about starting a company, my message is just do it. And with that, I'm going to say thank you and take any questions that you have.
So thank you, Helen, so much for an inspiring talk. I know most of us in the room are academics, and getting the research contributions out of the lab and into consumer products is very difficult. So we're happy to be able to learn from your successes. So we're happy to take some questions. There's some microphones in the aisles. If you could please come there to ask your questions, it'll be easier for us all to hear. It's hard to see. Any questions? Yes.
Yes, I was wondering, who have you sold some of the tethered flying robots to? Are they getting into the market or? Park.
Well, we're pushing it into the military market for force protection. We're going to have one flying at the DARPA Robotics Challenge. I think a lot of the community here is going to head down there. And yes, we're getting it into the market. So we're excited about that. The Pocket Flyer, we just started development a little while ago, so that's looking like 2016, get it on the market. I did want to say I'm happy to take questions now, but during the conference, if you have any questions, I know a lot of people here from way back. I'd love to meet a lot of the students, and just come up and talk to me.
Hi, I'm Harsham. I'm interested in knowing when the battery, is there any innovation happening specifically towards batteries in the drones so that we can put more sensors and we can put even manipulators and things like that?
I'm sorry, could you?
Yeah. Is there innovation happening on the battery side of the drones, which are batteries which are targeted towards the requirements of the drones? Batteries.
Oh, yeah, innovation in the batteries. Well, we didn't see any innovations in batteries coming along that would satisfy our customer need. That's why we did the tethered systems. I saw some, we always look at fuel cells, and you could put a fuel cells on a small drone, and they just started to have the power. Energy hasn't been a problem, but they just started to have the power that you need to run a drone. And yeah, there's been some look at joint liquid fuel and battery systems. Now, hobbyists have been using liquid fuels on, RC helicopters, which are really drones, for decades, and went away from that because the batteries are just so easy to use, and logistically, you just charge them like your cell phone. So I'm not sure how that's going to fly, so to speak. You can get more, you have 8 times more energy density in the liquid fuels, but you always have liquid you have to transport and deal with.
And the second part of the question was does the battery currently have enough fuel for putting sensors and manipulators, even your level 1, right?
Yeah.
Is there enough juice for customers enough juice in the battery so that they can put the sensors? Because initially, I think when you said you...
yeah. We're running a Kickstarter campaign, and we get comments and questions, and there's been a lot of comments. Can you put thermal sensing? Can you put night vision sensing? And, even some, can you attach a manipulation payload? So I think there is demand on the back end, and there is an appetite for consumers to do more. Now we're inspecting the gutters, but wouldn't it be nice if you could just clean out that, that leaf wad with the drone? Thank you. Okay, well, thanks very much, and I look forward to speaking with you at the show.
Thanks again. Thanks again, Helen. The technical sessions start at 9:15 on the 6th floor.